This screen capture is going to walk you through the construction of the standard curve to fulfill part A of the bacterial growth curve exercise. We have our data lined up on our spreadsheet, just as you have in your lab manual. And here are some sample OD600 readings. These aren't going to be the readings that you necessarily have. Let's fix that label there. It's OD600, not 60. But this is, we're going to use this as an example about how to calculate the cell concentration of the dilutions that you made, and we're going to use this formula over here in the box. So C1 times V1, that's concentration 1 times volume 1, is equal to C2 times V2, concentration 2 times volume 2. And our concentration 1 is going to be that original cell concentration in cells per ml. And we're going to use that formula to calculate the cell concentration of our dilutions in our different tubes that we made. So concentration 2 is what we're hoping to find. So let's rewrite this formula a little bit in order to do that. So it's going to be C1 times V1 divided by V2, and that's going to give us our missing element C2, our concentration in the diluted tubes that we made. So we're going to plug in our formula into this cell. C1 is our original concentration. It's 3 times 10 to the 9th. And we're going to multiply that by our V1, our volume of cell suspension that we added. That's contained in that cell. It's 3. And then we're going to divide that by our V2, which is the total volume in our tube, which is the amount of broth plus the amount of cell suspension. And then we're going to pull that formula down, and that will give us our calculated cells per ml in the dilution tubes that we made. We're going to create our standard curve by plotting our cell concentration against the ODs. And so we're going to select those two columns of data and insert a scatter chart. And then we'll add a trend line to that scatter chart. We select the data points and right click. And then we get this option to add trend line. And that's our best fit line. And we want to see the equation so that we can use it in part B. So we can display the equation. Let's make it a little bigger. And there we have the equation that we can now use to calculate cells per ml from any OD that we might choose or obtain experimentally. So Y here is going to be our calculated cell concentration, and then X in the equation is the OD. So in part B, we'll see how to use this equation with some simulated data.